Today we'll try something perhaps slightly different than usual. I'll try to code up a small project in Common Lisp that is controlling a piece of hardware. Being 4x20 alphanumeric LCD display. This is a very common type of display found in different sizes and variations, but all of them are controlled by a Hitachi controller, LCD controller chip. This has been mainlined into kernel many years ago. It is known as Auxdisplay in device tree, and what I needed for to make a menu system for upcoming controller to one of our devices. The choice of this display has been made because the PCB we use already have parallel output for this type of display, and it's a small thing to just enable the right size in the kernel, and the control will be done by a jog wheel which can be pressed. So there are three actions: rotate left, rotate right, select menu. And yeah, we have to see how we can make it in a usable menu in this petite size of screen. So first thing, let me crack up a fresh Common Lisp session. Right, maybe I should increase the font size a bit. Hope it's visible enough. One easy way to start a fresh project, as I remember, is quick project. Was it? This is a sort of make project, allows you to quickly set up a project here. So I use my normal path, that is trees, Lisp, local, yeah, and let us say, what do we call it? Something with menu, right? Menuet. Yeah, that would do it. What can we specify? The license. License would be then MIT. Easy choice. Template directory depends on what do we depend on. I don't think really need to depend on anything here. We can add it if we want something. Author is me. Name, I'm sure it can deduce the name from the path name of the project. So let's give it a try. Yeah. So trees, minuet. There is a directory now. Readme MD. We start working right here. First thing we do, we perhaps set up some sort of class for our display. Display, not very creative. and it's gonna have a path which would be path init path init form, which init form we would have. Sorry, it's a bit tiny, I guess. Let me zoom it up again. Which init form we'll have here. Yeah, dev lcd sounds like it. So in this shell, I am already logged in into the device that has the display connected, and oh no, it's gone. And that's why I like MOOCs. Yeah, we have dev LCD. So don't pay attention to time string here. It's just not set up right. It's October 2024 as we speak. And let me add some sort of test method. Let me first switch into Slime. Can't find it because we need to QL register local projects. Right. No, it's actually doesn't like the source file. Why? The package is there. Has to be something dumb. Oh, Jesus Christ. Of course. Rookie mistake. Let me see. Let us see if display is still alive. That thing should be clear in the screen. And it's not really much to do. This is a test. Right? Still a test. Yeah, we get that. We probably should enable. Yeah, here's my older string. We should probably enable the cursor, rather not the cursor but blinking cursor. Oddly enough, this display has, if you see here, this is the escape sequence to enable the blinking cursor, and this one is to disable underscore cursor. So it's a bit bizarre. A good thing to do probably is to code these sequences in the constants, and since we use constants, I want to use Alexandria package. Depends on right. Mix it up Emacs Lisp command with a slime command. So let me see. Now that we have system defined, let me reload it quickly, and it will pull Alexandria in. So Going back to Minuet, Alexandria, define constant. You know, some people like to inline like to include the packages. I sort of like to refer them by the names when I use libraries. I include usually my own subsystems packages into my project, but try to keep explicit references to outside packages. Makes it a bit easier. Okay, what do we call it? First constant gonna be also the CLS, like that. That would be it, right? No warnings. Now I wanted to enable the cursor, LCD cursor on, cursor off, and this is gonna be we need, I think, a sequence for home, and that's not an ANSI sequence, it's escape code H, I think, not an extended sequence. So this should be of course, we tried to redefine it and complained, and we define instead cursor home, right? Def method, why I use clause here? Is it necessary? Not really, probably. Just like to keep my globals, what can eventually creep in one place. And it's not really a performance sensitive part, the display. See, and right, what the method was. The method was write LCD. That's what we do here. Display string. So with open file, that's going to be our stream. File spec path D, direction output, if exists, append, right? We can append. I think that should do the trick, so we'll try a few simple things with that. And what do we do then? Write string what's wrong with you now? Oh, of course, write string. Don't be a dummy, Eugene. Let me see. Dev.var LCD. Display. Right, LCD. Dev LCD does not exist. No such file or directory. Okay, that was dump. The dumb thing, of course, that I opened a local Slime connection instead of connecting to a remote system. How often that happens to you? Probably not very often. Let me fire up a CCL instance on this machine. This is, by the way, a simple ARM system. Right, pretty outdated by the measures of current generation of desktop or even single board computers like Raspberry Pi, but it is robust, inexpensive, and it's certified to all possible industrial applications, unlike some other single board systems, including Raspberry Pi. So let me see. We have loaded, so let's attach with Slime. Slime connect 10.0.15.56. Not closing anything. Here we go. QL Regis local projects. Right. System Menuet. Right, now we're on the same page. Let me see. Right, LCD. Yes, I need to kind of find variable. Of course, the package has to be right as well. Do we have it? I think we have it. That's a start. Let me clear the screen. What is our LCD CLS? No, let's start. Try home cursor home first. Yeah, naturally, the problem here is I copied it from shell and it doesn't do shell string evaluation here, so I have to substitute everything to actual character codes. So okay, let us think a bit more clearly. How do we represent the symbols? This is a hex code for escape character in ASCII. So we can do with output to string, perhaps. String code char. No, I don't need code char really. Print escape. And format the rest as not nil, as naturally. Cursor home. right. So that should be corresponding to this guy here. Let's try it against the display. No, cursor didn't budge. Let me just insert it verbatim, I'm not sure. Still nothing. Yeah, that's pretty dumb. You see what I did. A rookie mistake, now it works. So, how do we clear screen? For clear screen there was another old school sequence. I think /F is an acronym for the driver specifically for Auxdisplay driver in Linux. It's nothing standard, but it was 2J or J2 or something along this line. I think it was 2J. Let us try 2J. Voila, we got it. So what I'll do then, I just substituted here in LCD CLS, right? Insert this to this one, right? We're gonna complain, try to redefine the constant, similarly we'll do here, just use the different values, right? Yeah, you know what, it doesn't look pretty. Let me do like that, and this is gonna have right. Now we can simplify that a bit with escaped like that. Do you think it's prettier? I think it is. Let's do the same here. Oh. Again, was it J2 or 2J? 2J, I think. Like that. Yes. Oh, wait. What do we do? I'm stuck. Wow. No. bring me back here. Escaped. No, it was correct. Escaped. This one is fine. This one. Idiotic. 1, 0. I kind of expected to complain about constant, but it complained about something else, right? So this one as well. Redefine the constant. And here cursor home. Right. I just make it a tad smaller maybe, so that it fits the screen better. Now let's format hello governor. Yeah, cursor home, cursor home, cursor off, cursor on, and CLS. What? Yeah, I know why. I get it, I get it. This remote session feels kind of weird. Yeah. What I'll add here is return true so that it doesn't bomb with control characters on the way out. And let us see what can we do. Should have this session keep alive somehow. What can we do? Okay, now we can output simple stuff on the screen. There are ways to control the screen. Let me see if I can dig up. There was a special control character for moving the cursor and for scrolling the screen. So thing is, with this screen, I don't think the Hitachi display controller can actually invert the characters. It can invert probably the whole display on some issues of display, but it can't reverse single character. So you can invert characters to highlight the current menu item. You have to sort of rely on this already existing cursor, or you have to do some creative indication with character symbols, maybe an arrow or angle bracket to indicate current menu choice. If you look at the display size, you probably can split it 4-way in 4 areas of menus, and then you can use jog wheel to hop from menu point to menu point. But this kind of inconvenient, and the refresh time on this display is not great, so you have to blank and redraw areas as you move and activate menus. A clear screen is fast, but displaying new text takes a bit of time. So one thought I had is to add a scrolling option from left to right, such that if you turn the jog wheel left and right, then it swipes out the menus in a kind of whooshy dynamic effect. But let us add first some more constants, I guess. A cursor. There is no cursor up and cursor down. I think there is also a cursor left, and that would be a LL. And cursor right. LR. Right. Let me. No. Lowercase. Let me try that one. Wait, what? We already left, right? Let's say right. Yeah, it works. Yeah, it works both ways. But point is to go up and down. There isn't really convenient thing. Maybe I can use a new line if it doesn't blank out the next line, but it's gonna be slow, and I have to always operate from a known reference, either by keeping track where cursor is all the time and doing the math where the cursor should go from that point, or resetting to home position and redoing the movements to menu items positions. It's slow and not pretty, especially if I have to enable blinking cursor on and off. I don't know yet how to highlight it. So I think I go actually for scrolling menus. For those I need let's call it scroll left. And if I remember, like, those are just capital versions. Scroll right. So how about we try it now? We need some text, I guess. Hello, governor. A new line. Perhaps I just add that one here. Or I can actually do that in format strings if I want to. Right, we have format and friends. That's I kind of escaped my mind. So what we can do, I guess, we can format new line like that. More. And this brings me that it was a great point with format. We could just remove all the thing and do format the string like that, you know. Right. See, the value is the same, it doesn't redefine. So don't really need a function, could well do in the constants, but pretty that way. And what do we do then? We do this too. Scroll left, scroll right. We have now some text to scroll out. Let's scroll right first. So fantastic. Okay, that's the step one. So you get to see my idea. We turn the thumb wheel, debounce it, and with the thumb wheel action, it will slide right off the screen and new menu will be printed. Should be pretty awesome. For that, I guess I don't really need any cursor anymore. Let me disable it. Right. Right in the middle with text. Right, so we have a 20 character wide display. So to clear our screen, we need to go 20 characters either way. Although we can cheat and just clear the screen in the last few characters, nobody would care. So let us make a function to scroll out smoothly. Scroll out right first. And here we do right LCD D naturally we write the LCD scroll right. That in itself doesn't do much, so let us loop like that. Scroll out right. I'll say the wow. Yeah, it goes in circle, it gets back immediately, and we need some delay after that. Let me say if we do some what am I doing here? Right. Sleep. Sleep how much? Sleep 4.1. Gonna be too slow perhaps, but let us try. Let's see. We'll add the coefficient. What would give us a slightly different. Let's try with from 1, which is full slowness. The 0. like that. And what we're gonna do here, sleep, will multiply this by sinus. No, that's not gonna do it. Say p2 sinus like that. Stupid for some people, you know, they use keywords that you can see right away what it does. I just can't be arsed, but it has its advantages, I guess. It absolutely makes no difference. Yeah, it's instantaneous like that. So like sin 0, 0, sin 1, sin p by 2. Okay. I don't know, doesn't really make anything, but you know, maybe I'm overthinking it. I don't really need any sign, I just need a decaying fast enough coefficient. We're getting there. Yeah, ain't too bad, you think? And if we add 4 times as slow, something like that may be better. Yeah, sweet. Make an identical one. I don't think I need I don't think I need even to specify that. Yeah. Oh no, what have I done? Does scrolling left work the same way? We'll find out now. Yeah, it would if I defined it. Yeah, so we have a slight problem. As you see, the buffer is circular, which means the menu is not going to disappear really. So it needs a bit different strategy, I guess. I wonder if I should kill the lines somehow. There is an option, I think there is an sequence supported in the kernel that allows you to kill the rest of the line, kind of counter K work in Emacs. But problem with that, I would need to move cursor to the end of each line in the current position and perform the kills while we iterate. Okay, let us try define test. kind of long, I guess, but let us do that first. Just to, fill the screen. Define. I haven't programmed a scheme in ages, but it's somehow crept in, Just it would help if I could type. Yeah, what do we have here? A bit too long. It looks a bit too long. Well, let's trim it a bit. Yeah, that gonna do. Scroll out right. Of course. So what we're gonna try now? User Apple a bit. What we're gonna try now is to scroll halfways down to 5. That's so stupid. So if we scroll twice, we'll do a full scroll, kind of. Anyway, what we try now we add the immediate clear screen, like that. So it kind of, test. If we just for test's sake write test here as well. And we don't need to do clear screen really on test. Yeah, problem is position doesn't change, it still writes in the same position. So it shifts the home position, I guess. And there is a way to reset that. I think it's initialize. Let me see. LCD init escape L. I think it's reinitialize display. It's called really. I of course can shift back immediately the same amount of positions. Or I can try initialize. It's nice to have anyway. Actually, like that, I think. It doesn't like it. LCD init. So instead of clear screen, that's pretty terrible. Okay, that's a useful sequence, but not something we're gonna use much, I think. Let me grab this test function we defined and just just copy it here so that we have it at hand. No, that's pretty ugly. So what I do, I scroll back. We kill all that, right? Or we keep it clear the screen. Right, we remove the sleep. We remove this here, I guess. Here. We remove all that, and after clear screen we write LCD SSD LCD scroll right by the same amount positions, which is 10. Loop repeat 10. Do right. Scroll out left. At least position is consistent. The position is consistent, no? I don't know about speed, you know. No, it doesn't scroll enough. Still. No. LCD scroll right. Yeah, that's because it's probably off. Oh my god. Time for browser loop for black belts. I am an old guy looking into the old book. Down to Can I go down to without specifying the limits? That's the thing. Down from. Down from. Oh my god, it has down from. I had no idea. I learned it just today. Down from 1. Down from 1. Like that. Maybe it will fix it. Okay. I don't care. Let me... This will not abort. Can't really think straight. Let me do it like that. Max 0. Like that. Is it consistent? Just start from the scratch. Well, it's something. We'll see what we can help it later, but we'll now clone it into write function again. Write. You know, all these timings. Can be done away. All these timings can be done with this. We just kill, right? So we can write test, and we can scroll out right. Yeah, you get the idea. So I think we have a start to work with here. And next thing is to think through how the menu tree are done and accessed and handled with displaying on this display. It's going to be naturally a state machine. Maybe define it as an A list with states and menu texts, eventually maybe some pseudographic buttons and callbacks to functions that actually do the work for the menus. But that's for later. So thank you for today. The follow-up I hope is coming soon. See you later.